Okay, so in this video I'm going to review some of the problems that I set looking at forces, impulses and Newton's second law, and it's going to be done in the context of scenarios in Game of Thrones. So let's start off straight away. So we've got a scenario, so to accelerate a sword, Khal Drogo applies a force of 100 newtons for 2 seconds. The sword has a mass of 10 kilograms, calculate the final velocity. So what we can do is we can calculate the impulse that has acted on the sword first of all. So that is going to be 200 times by 2, so it's going to be 400 Newton seconds. So we know an impulse is defined as a change in momentum. So we know that essentially the change in momentum of the sword was 400 Newton seconds. So we can then calculate what the change in the velocity was. It's going to be the change in momentum divided by the mass, which is 10. So it's 40 meters per second, and it started at 0, so then the final velocity therefore would be 40 meters per second because it started at 0 meters per second. So that's that one, quite a basic question. Okay, so let's have a look at the extra practice at the level. Okay, so we've got Arya Stark, and she's got a much lighter sword called the Needle, and we've got to 10 meters per second, got a mass of 5 kilograms, calculate the force. So essentially what we can do is we can do this problem, it's like the reverse of the first one, so the change in momentum is going to be the final momentum minus the initial momentum. So the final momentum is going to be mass times it's going to be like that because the mass is the same for both. So it's going to be 5 kilograms times by 10 minus 0. So it's going to be 50 Newton seconds. Okay, so we know that force times time is equal to the change in momentum. That's using Newton's law. So the force is going to be the change in momentum over time. So it's going to be 50 divided by 1 second. So it's going to be a force of 50 newtons to cause that change in momentum. So that's the basic level. So let's move up to something a little bit more in depth. So we've got a graph here, a velocity time graph. So what we've got is Jon Snow running away, and we've got a graph showing 10 seconds. So essentially what it's telling you is the graph stops at 10 seconds, and it tells you later on that it reaches a maximum speed of 6 meters per second. Okay, so it's asked for the average force. So the average force is just going to be the mass times the acceleration, but the average acceleration, so which is going to be the mass times by change in velocity over change in time. So we've got 80 kilograms times by 6 divided by 10. So that's going to give you an average force of 48 newtons over that period there. So the shape of the graph is actually irrelevant. All you're interested in is the change in velocity, the time, and then you can work out the average force. The peak force might be bigger than that, but that's not what was asked for. So let's have a look at another question with a graph. So we've got Jon Snow throwing a 5 kilogram rock over a period of 0.2 seconds. So this takes 0.2 seconds, and it tells you the maximum is 200 newtons. So the first thing is to work out the impulse is the area. Because it's a triangle, that's going to be half times base times by height. So that's going to be 20 Newton seconds there. And so we're trying to get to the final velocity. So we know that the change in momentum of the object is going to be 20 newton seconds, which means the change in velocity is going to be 20 divided by 5, so it's going to be 4.0 meters per second. So if it started stationary, its final velocity is going to be 4.0 meters per second there, because it started stationary. Okay, so those are those ones. So let's have a look at a multi-stage problem, putting these things to the test. So we've got Eddard Stark here, easily the best character in the first series of Game of Thrones. But anyway, he's got a ridiculously big sword made of Valyrian steel. It's about 50 kilograms is my estimate here. And to be useful as a sword, you're going to need to be able to get it up to speed, because that's how you're going to slice someone with it. So it tells you each of Stark's arms can generate 2,000 newton. So the first thing to do is the total force is going to be 4,000 newtons there. That's the maximum possible force. So it's asking whether a slash could be executed in 0.25 seconds. So what we're going to do is work out change in momentum is force times by the time. So that's going to be 4,000 times 0.25. So it's going to be 1,000 newton seconds. That's the change in maximum change in momentum possible during that period of time. So then we know that the change in velocity is going to be 1,000 divided by 50, which gives you a 20 meters per second maximum speed that is achievable there by dividing by the mass. So in 0.25 seconds you can get up to 20 meters per second. Therefore, yes, absolutely, he could reach 15 meters per second. And what we've done is actually answer, by doing this calculation, we've actually also answered part 2, which is why I chose this particular method. You could have also done it by calculating the time it would take to get to 15 meters per second and working out it's less than 0.25. That would be fine as well. And then to part 3, so this is essentially part 1 and 2. If Stark wants to achieve a maximum speed of 25 meters per second, suggest some modifications he would make. Okay, so if he's going to need to reach a higher speed, he's going to need to achieve a higher momentum. And the way to do that is essentially you're going to need to increase the impulse that's acting on the sword. So we've got 2 options here. We could increase the force, so you might need to go along to the gym, do some weightlifting, lift some rocks or whatever it is, so he can provide a larger force. Or he could increase the length of time which he is swinging the sword. Again, that will result in achieving a higher momentum there. The other option might be if you actually change sword, you could essentially decrease the mass of your sword, so then you wouldn't need to get to as high a momentum to have this speed. That might be your third option there, but without changing the sword, you need to be able to increase the force or increase the time. That's the answer to that one. Okay, so let's look at the last question on this problem. So we got Tyrion here, another fantastic character. So he would definitely use a crossbow rather than a sword because he's not an idiot and needs to kill people at range. So what we've got here is we've got a Dothraki horseman. Will die if he's struck by a 15 newton, something that supplies a force of 15 newtons, because he's not wearing any armour. So what we've got is you fired an arrow with a speed of 40, but we've got an air resistance force acting against it during this flight time. So let's first of all work out what the initial momentum is. So it's going to be mass times the initial velocity. So the mass of the arrow is 0.1, velocity is 40, so it's going to be 4.0 newton seconds. Now, as we can see here, it's got a force acting against it during the flight, so it's going to lose some momentum during the flight. So it's going to be the force of resistance times the time it acts. So it's going to be 0.2 times 2. So it's going to lose 0.4 Newton seconds during the flight. So the momentum when it hits is going to be 3.6 Newton seconds, because that's how much momentum is left. So then the force is going to be the change of momentum. So when it strikes the person, it's going to become stationary. So it's going to change from 3.6 momentum to 0. And it's going to do it during 0.05 seconds. That's what it says in the question. That's the collision time. And then, so what we get if we do that is we'll get an answer of 17.2 newtons, which is greater than the 50 for a fatal hit. So that's part 1 there. So part 2, calculate the maximum flight time if everything else remains the same for a kill. So we know that for a kill, the force has to be 50 newtons, which means the momentum when it hits is going to need to be 50 times 0.05, which is going to be 2.5 Newton seconds. So the hit momentum was the initial momentum minus the momentum loss. So what we can do is we know the hit is 2.5, we know the initial momentum was 4, so we can essentially calculate that the momentum it can afford to lose in flight is 1.5 Newton seconds. So time is going to be the momentum divided by the force, because the momentum would be force times time. So it's 1.5 divided by a force of 0.2. And that's going to give you a flight time of 7.5 seconds there. So the key here was working out how much momentum it needed to have when it hit. So then you can work out using this and this what the loss was, because you've got this as 4 before, then rearrange. So momentum would be, the change of momentum would be force time. And then we can essentially calculate the time. So part 3, determine whether it's possible to kill the Dothraki if they wear an armour that doubles the force required. So let's have a look at that. So if the force is 100 newtons, the hit momentum would have to be 100 times 0.05, which is going to be 5 Newton seconds, but we should notice the hit momentum is actually greater than the initial momentum, so it's impossible there, because we know it starts with 4, so you can't arrive with 5 at the point it hits the person, so that's an impossibility there. Time.